Alright, starting out in Chapter 2 of Section 1, the two problems I'm going to do for you to help you out with your homework today is going to be finding the vertex point, x-intercepts, axis of symmetry, and sketching the graph both with and without a calculator. So we'll do this problem first without a calculator, and I'll show you how to do it with it. And then we're going to take a look at a problem that's kind of like number 75 in the homework, where I believe 75 has a farmer, and this is basically identical other than I've switched some numbers around, maybe the number of pens. But it's a story problem where they ask you to write the area as a function of x and then find the dimension. So if you're stuck on number 75, this would be a good one to look at. But starting out here with this one. Alright, it's asking you to find the vertex point, x-intercepts, axis of symmetry, and then sketch the graph of, and hopefully you recognize because of the x squared that that's a parabola. So I should be able to at least identify that that's a parabola. And I'm going to do this without a calculator to start with. So to find the vertex point, I know I would like to have this parabola in vertex form. That's where it's y is equal to a, and then parentheses squared plus k. Of course, that means I have to complete the square. However, if I remember how x equals negative b over 2a works, I know that that's actually a shortcut for completing the square. So I'm going to do that instead. And so here's my a, b, and c. We obviously don't need c. But running through that little formula, I have negative b, which is going to be negative 3, divided by 2 times a, which is negative 1/3. And so my x value can cancel the two negatives. It's going to be 3 divided by 2/3. And if I multiply by the reciprocal, remember that's 3 over 1, multiply by the reciprocal, that's eventually going to give me 9 over 2. So that's my x value. Again, you probably prefer to have something like 5, but same thing. Alright, now to get the y value of the vertex, I'm going to take this x value and plug it back into this equation. So y is equal to negative 1/3 times 9 over 2 squared plus 3 times 9 over 2 minus 6. Remember, you want to square first, so this is going to equal negative 1/3 times, this is a fraction, they're being multiplied or divided so you can square them individually. It's 81 over 4. Here, I'm just going to multiply my numerators together to get 27 over 2, and then I'm just going to leave the 6 alone for now. Anytime you're going to multiply something like this together, you want to try to simplify if you can, and I know that 3 will go into 81 27 times. So that first number is actually negative 27/4. Because I'm adding fractions together, it's probably a good idea to get a common denominator. I'm going to change this to 54/4, multiplying both numerator and denominator by 2. And then I'll change this into 24/4. And that little trick that I told you is kind of helpful. If you look at the first two numbers, one of them should always be twice as large as the other, and you can see that this is twice as large as that one. That tells you that that number is right and your calculations are right. If for some reason one of them is not twice as large, that means either you did your calculations here wrong or that's not the right number. So that's good news. So it looks like that's going to give me positive 27/4 minus 24/4, or my y value is 3/4. So my vertex point, I'll write it up here, is 9/2 3/4. Again, not numbers you probably want to have, but if you can do it with fractions like this, and you can do it when the numbers are easy. So 9/2, that's in between 4 and 5. 1, 2, 3, 4.5, somewhere in there. 3/4 I'll approximate. Looks like it's right about there. So there's my vertex point. Looking back at my equation, I can see it's negative, so I know this is opening down. If I wanted to just rough sketch it, I could do it. I can also remember you can use that a value kind of like a slope. It's saying go down 1 unit, go both to the right and to the left 3. And you can only do this for these first points. You can't continue to do it after that. And this would give you a pretty good idea of what this graph would look like. Or of course I can just go ahead and find the actual x-intercepts, and that would do it too. Now once you get the vertex point, the very next thing that I would find is the axis of symmetry. The reason I do that is the axis of symmetry is always going to cut the parabola in half. It's a vertical line, because all our parabolas right now are going to be opening either up or down. It's a vertical line, which means it's x is equal to, and it's always x is equal to the x value of the vertex point. So in terms of the axis of symmetry, I know that this is going to be x is equal to 9/2. Alright, only thing I have left to figure out is what the x-intercepts are, so I'll come over here and do that. That of course means I need to either try to factor or use the quadratic formula. Now if you are going to try to factor something like that, even if you have to use the quadratic formula, remember you want to set this equal to 0 first of all. That's why we call them zeros a lot of times. I would probably try to get that to be a better number. You know, if it was 5, that would probably be fine, but a lot of times if that's 1, that makes it easy. So I'm going to multiply everything by -3. It'll just make my life a lot easier, especially if I have to use the quadratic formula. That's going to give me positive x squared minus 9x plus 18 is equal to 0. And now I can try to factor that, and if I don't see how to factor it or I don't end up finding it correctly, it's fine. I'll eventually get it by using the quadratic formula, but you should be able to factor this into x minus 3 and x minus 6. So if you don't see those factors, that's something you definitely want to practice because you're going to need to be able to factor it when it can factor. And so I know that my x-intercepts are x equals 3 and x equals 6. And there are my x-intercepts. You don't necessarily need to say that it's the 0.30 and the 0.60, but that's really what you're finding is 2 points. Alright, so I've got all the information I need. We already drew the rough sketch. If you wanted to come over here and say 1, 2, 3, there's my x-intercept, 4, 5, 6, there's my x-intercept, and now I can draw that more accurately. That would probably be a good idea. Since you have to find the x-intercepts, I would say actually graph those. If all I asked you to do is rough sketch it, find the vertex point, and then you can use that little slope idea, and that would be fine. Alright, so now let's do this using our calculator. So if this is on the test where you have a calculator part, I wouldn't need to necessarily see any work. All you'd have to do is plug your information in. So what you're going to want to do is go to y is equal to, it's in the very top left corner. Hit that. If you have anything in here, go ahead and just hit clear to get that out. Some of you, and this is important, if you see that this or any of these are highlighted, a lot of times that'll interfere with your graph. So just go up to the one that's highlighted and hit enter, and that should turn it off. Alright, and now I'm going to enter that equation into my graph. Whenever you have to type a negative, like -5, not actually a minus sign, but a negative, you need to use this button on the very bottom. If you use the minus sign, your calculator is going to end up giving you an error. So make sure that you're using this when you have to type in negative whatever. So I'm going to hit negative. And now I have a fraction. You could probably hit 0.333 and it would be close enough, but I would not recommend doing that. I'm going to put parenthesis 1 divided by 3 so I have the actual number. And then your x variable is right here. It's next to the green alpha button. It's got a bunch of different options, but when you hit that, it should come up x. If it doesn't, it's something you should let me know and I can fix that for you. It's an easy little fix. And then it's squared. I'm going to go ahead and hit my little caret button here. This is my exponent button right here, right underneath the clear button. And then I'm going to say squared. If your calculator is like mine, you don't need to do anything else. Just keep typing it in. If yours, after you hit that little caret button, gave you a little box up on the top, and you put the 2, you're going to have to arrow to the right to get out of that box. Alright, finishing it off, I have plus 3x minus 6. And then I'm going to go ahead and hit enter. And then my graph button is at the far top right. I'm going to hit graph, and it's going to go ahead and draw a picture of the graph for me. And you can see if you compare this graph to the graph that we drew, yeah, that's pretty accurate. I'd say we were fairly close. Alright, if for some reason you go to graph, and can you see that you have little tick marks here on the x-axis and little tick marks on the y-axis? If you notice that you don't see those tick marks, that means someone's probably messed around with your calculator. If that ever happens, and you want to see the normal 10 by 10 window, hit zoom, and then number 6 says standard. If you hit zoom 6, it'll bring you to this window all the time. And sometimes that's going to be good. You'll see as we get through chapter 2, we're going to have to learn to do other stuff with our calculator. But for right now, this is the screen that we want to look at. Alright, so now I got the graph. How do I find the vertex point? Well, since this parabola opens down, the vertex point is actually the maximum. So, and this is going to be important, you're going to use this specific spot in your calculator a lot. You're going to hit second, and then if you see the trace button right here, right up above it, it says calc. That's why we hit second. It's second and then trace. And it brings you to this window. And you will use this quite a bit. We will use almost all of these by the time the year is over. I'm looking for the vertex point. It doesn't say anything about vertex point, but like we said, our vertex point is a maximum. So I'm going to pick number 4, maximum. You can either scroll down to number 4 and hit enter, or actually hit number 4 in your calculator. And then notice what it asks you for. It says left bound. It wants you to pick something to the left of that actual vertex point. So you can see the little cursor right here. I'm just going to make sure I'm somewhere to the left of this x value. Doesn't matter where. And then I'm going to hit enter. Notice the question it asks me now. It says right bound. It needs you to be somewhere to the right of that vertex point. So you're going to scroll until you're somewhere to the right of it. Doesn't matter if you're here or if you go way over here. It won't make a difference. You're going to hit enter once you're somewhere on the right of it. And notice now it says guess. Notice up here it's giving you 2 little arrows. You are basically telling your calculator to only look in between there. And now when it says guess, what I tend to do is I just go back 1 to the left, hit enter, and the calculator will figure out the actual vertex point. And you can see it's 4.5. Now it's actually 4.5 or 9 halves. The calculator will do some weird things like this, so don't be thrown off by that. It is definitely 9 halves or 4.5 and 0.75 or 3/4. I prefer that you actually write the fractions, please. Alright, so there's how I find the vertex point. So, now how do I find the x-intercepts? Well, let's go back to that exact same spot, that second trace. And you probably notice that it says 0. Remember, that's a fancy way of saying x-intercept. So I'm simply going to go down to number 2, or like I said, you can just hit number 2. And it's going to ask you the same questions. Left bound. Well, I have 2 x-intercepts here, so if I want to find that one, I need to make sure I'm somewhere to the left of it. Hit enter. Ask me somewhere on the right of it. So I'm going to go somewhere to the right of that x-intercept. Now be careful, I have 2 x-intercepts, so if I go to the right of the second x-intercept, the calculator's not going to know which one I'm dealing with. So I need to stay in between these. So I'm somewhere to the right of that x-intercept, hit enter. It says guess, just go back to the left one, hit enter, and there it is. It's 3, 0, which of course we figured out algebraically. And then if you want the other one, it's just do the same thing. Go second, calc or trace, pick number 2 again, be on the left side of this x-intercept, then go on the right side of it, make your guess, and it'll tell you that it's 6, 0. So really, really nice when you end up with some horrible numbers. If you ended up with, say, 2 plus square root of 6 over 5, this would give you a decimal approximation. That would be fine when you're dealing with the calculator. But a nice little thing to know. It said second trace. Important, you will use it a lot. Alright, I'm just going to go ahead and clear that off, turn my calculator off. Then I'm going to jump down to the last question that we'll look at for this particular section. And that, like I said, it goes along with number 75. The zookeeper has 400 feet of fencing to enclose 3 adjacent pens. It wants you to write the area as a function of x. Now for 75, they give you a picture of what they're talking about, so it makes it a little easier. I'm just going to go ahead and draw one out. Now I've got some sort of rectangular pen, and there's 3 pens here altogether. These are supposed to be equal size, so forgive my drawing. And it says I have 400 feet of fencing. Well, you can label these sides kind of however you want. It won't make a difference in the end. If I say that that distance is x, remember these are all supposed to be the same, that means this distance is x, this distance is x, or this entire distance is 3x. I could say that this distance is y. It's most likely a different length, so I can't use the same variable. And now look back at this. A lot of times when you're working with a rectangle, in terms of geometry, you're probably finding either a perimeter or area. They want me to find the area. Well, I know the area of that rectangle is going to be base times height. Well, the base is 3x. The height is y. Now, I say that you can do this kind of how you want. You could ignore this, and you could actually just say that this entire base is x. And that would be x times y, and that would be fine. It won't change the problem at all. I'm not going to do that. I'm going to leave these as x, but it actually will not change your problem. The numbers are going to look different, but eventually it'll all work out the same, so I should maybe scribble that out. Alright, that's not what they want. They don't want the area to have y in it. They want it to be a function of x. I need to get rid of that. So there must be a reason they told me this 400 feet. If you measured this distance, all of this, this, and this, they're saying that that's 400 feet. Well, that's kind of like a perimeter. The measuring of the outside of this rectangle is the perimeter. I'm going to add a little to it. So they're in a roundabout way giving me the perimeter. Now think about how many of these X's I have. I have 1, 2, 3, 4, 5, 6 of them. And then think about how many Y's. I have 1, 2, 3, 4 of them. And they're saying that all of those sides added together is going to equal 400. Now again, why would they give me that? Well, here's what I want for a final answer, but I don't want Y there. Well, look what I can do here. I can solve for Y and it would have X in it. So that's what I'm going to do, is I'm going to subtract the 6X, and then I'm going to, that's just 4, I'm going to divide both sides by 4, and I'm going to simplify both separately. So it's going to be divided by 4, and simplify. And now I can take this, which is what Y is equal to, and plug it in here. So that I get A is equal to 3X times Y, but a better way of having Y now in terms of X is 100 minus 3 halves X. And now I've done what they've asked me to do. I have written the area as a function of X. Probably going to simplify it a little bit. So I'm going to say this is 300X minus 9 over 2 X squared. There is my area in terms of X. So there's what letter A wants you to do. Alright, so I said very similar to what you're going to be doing in 75. The second part of this says find the dimensions that will maximize the area. Maximize the area. Think about what we mean here. Maximize. Look at this graph that we did for the last problem. We said that the vertex point was the maximum. Maximizing it means it wants me to find the vertex point. Well, this is a parabola. It's opening down. Makes sense that I would be finding a max. So, vertex point, if you had a calculator, you could easily just plug it in your calculator. Or I'm going to do x is equal to negative b over 2a again. Now be careful, that's actually a, that's b. So I'm going to have negative 300 divided by, if I multiply that by 2, the 2 would cancel. It's going to be just negative 9. I can cancel those out. And then if I want to simplify, I know that 3 goes into both of those. So this would be 100 over 3. There's the x value. Now the x value for this maximum represents that actual distance of x. The y value for the vertex point would actually represent the maximum area. I don't want to know what is the maximum area. I want to know what the dimensions are. I have 3 of these things. So my dimension here would be 3 times 100 thirds, or 100. I need to know what this is. Well, how am I going to figure that out? Let's go right back to that equation. This is an x value. If I plug that in for x, I can figure out what y is. So y is going to equal 100 minus 3 over 2 times x, and x is 100 over 3. 3's are going to cancel, so I have 100 minus 50. Or this y value is actually 50. So the dimensions are 100 thirds, 100 thirds, 100 thirds. Add them together, that's 100 by 50. So the dimensions of this pen would be 100 by 50. And that's the actual answer that they're looking for. If they wanted to know what is the maximum area, not the dimensions that give it, I would need to plug this back into this equation to figure out the y value. Alright, hopefully that helps with 75, and hopefully that'll help with section 2.1. If you have any questions, feel free to let me know.